So in this problem, we want to find the area of the region bounded by the graphs of these two equations. And we're not given any graphs, so we're going to have to figure out how to set up our integral. And it helps very much to have a visual. So I'm going to start by graphing them, but actually even before I graph them, I'm going to figure out where they intersect, right? It's implied that these two graphs must intersect twice. And that we're going to find the area in between those 2 points. So to find where they intersect, we're going to set them equal. So where does 7x minus x squared equal 3x? And we'll solve that for x. So I'm going to subtract 3x from both sides and add x. Why am I doing that? Let's just leave it all on the left. So 4x minus x squared equals 0. That way I can factor out an x, and I'm left with 4 minus x. So these intersect at x equals 0 and 4. So that gives me an idea of my x values that I need to graph. So right here I've got 0, 1, 2, 3, 4. Okay, y equals 3x. When x is 4, we can plug 4 into either equation to get the corresponding y value. When x is 0, y is 3 times 0, or also 0. And when x is 4, y is 3 times 4, or 12. So they must intersect at both 0, 0, and let's just call that 12 right there, and at 4, 12. Okay, graphing the line y equals 3x is pretty straightforward. It's just a straight line through those 2 points. Graphing this quadratic is a little bit more advanced. So 7x minus x squared has a negative leading coefficient in front of that leading term x squared. So it's a parabola that opens downward. Let's just see real quickly what x value the max is at, just to get a semi-decent graph. The maximum occurs at negative b over 2a. So b is 7, so negative 7 over 2. A is negative 1, so positive 7 halves, or 3.5. So the max occurs in there, and I don't know what the y value is, but it's got to be, if it's opening down, it must be doing something like this, right? And you can check by plugging in a y value if you want. The point is just simply that the parabola is greater than the linear function for x values between 0 and 4. And it's important which one is on top because that helps us know how to set up our integral. Okay, we're going from 0 to 4 are our limits of integration. And then when we set up the area between two functions, it's the area, or it's the first function, the one on top, minus the lower function. That's our integrand. So the parabola is on top for that interval, so 7x minus x squared, minus the lower function is the linear one in this case, so minus 3x. So we have the integral from 0 to 4 of, before we differentiate, let's go ahead and simplify. 7x minus 3x is 4x minus x squared. And from here, it's just computational, finding the antiderivative, plugging in and subtracting. So the antiderivative of 4x is 4 over 2, or 2x squared, minus a third x cubed, and we'll evaluate that from 0 to 4. So you'd plug in 4 minus plug in 0 to get your exact answer.